Hello everyone. Guys, in this lecture, we will do some numericals and we will solve some numericals and equations on the topic of equilibrium constant. And after solving these numericals, you will be in a better position if the question comes on writing the expression or solving the numericals of equilibrium constant, then you will be able to solve these questions in your examination hall. Now, before solving any question in the examination, guys, please remember that these such type of questions, in such type of questions, you have to look for what is being asked. Here, first of all, you have to write the expression, and they are saying write the expression for the equilibrium constant Kc. I have told you in the last lecture that you have to write the equilibrium constant as Kc, not as Ke. Okay, it is known as Kc for each of the following reactions. Now some reactions are given to you. Never get confused. These are very easy. First of all, I have told you about the rules in the last lecture that you have to ignore pure solids and pure liquids also while taking into consideration the equilibrium or equilibrium constant. Now you will see in your examination hall in your question paper that they will give you expressions like G, this is gas, S is solid, so that means we have to ignore this. This is also solid, we have to ignore this. This is gas, this is gas. We have to take this into consideration. Rule number 2, just remember guys that after looking for all these things, you know that this LHS side after the reaction, after the equilibrium symbol which is given there, this LHS side and RHS side, right hand side and left hand side, you know that LHS side denotes reactions, reactants. It denotes reactants. And this is the product of reaction. You can call this as reaction or simply the products of reaction. And you know that you have to write the products as numerator. You have to write the products as numerator and reactants as denominator. Don't forget this. All these things I have told you already in the previous lecture. So on the basis of this knowledge, let's solve these numericals. Question is saying to us that write the expression for the equilibrium constant Kc. We are writing Kc and our first reaction is given as 2NOCl, which is the gas. We will take this into consideration because this is a gas. Now it is a forward process and this is a reactant and it is just giving birth to the products of 2NO, which is a gas, and Cl2 again, which is a gas. So all these gases we have to take into consideration according to a rule. We just need to ignore pure solids and pure liquids. So how we will write these expressions in examination? First of all, we know that in numerator, while writing the expression, we take products and in the denominator we take reactants. So let's take the products in the numerator part. We will write this simply as, first ignore the numbers. We will write this as NO, okay, capital C, capital T, okay, Cl2, okay. Now with NO, you have to write this number 2. It will written as NO2. For Cl, there is no number given. So we will leave it by writing Cl2 simply in the bracket. Then in the denominator part, we have to take LHS side, which is the reactant side. And since this is gas, we will take this into consideration. We will simply gonna write NOCl. This will be our bracket, capital A, capital B, okay, and raised to the power 2, which is our stoichiometric coefficient, or we can consider it as mole according to the molarity concept. So this is the perfect expression that you have to write for this first reaction. Now for the second reaction, it appears as a bit technical, but remember the rules. You have to ignore pure solids, you have to ignore pure liquids. So here this is solid, we will ignore this because this is given as solid. This is solid, again we will ignore this. This is gas, we will take this into consideration. Again this is gas, we will take this into consideration. Now how we will write the Kc, how we will denote the equilibrium constant for the second equation. So we know that first we need to take RHS side, which is our product side, and we will ignore this 2CuO because this is solid and we have to ignore the solid according to our rule. We will take both these into consideration because these are given as gases. So we will write NO2, which is C, okay, C raised to the power small c, and small c is given as, mole is given as number 4. And then we will write O2, and since nothing is given in this O2, so we will take this as raised to the power 1 or simply O2. Now many students get confused that if LHS, if the side of the reactants that we have to take into denominator, if this is given as solid, and solid we have to ignore according to our rule, pure solids and pure liquids are ignored, so this is given as solid. So what we will write, because now this side have to be ignored, simply write 1, okay. So your expression will become simply as NO2 in the bracket raised to the power 4, then O2 raised to the power 1 or simply O2. So this is our expression for reaction 1, okay, and this is our expression for reaction 2. This is how, friends, you have to write Kc in the form of reactions for various numericals that will come in your examination. Now guys, let's solve this question. Second question. The question says that first let's solve this question because this is the numerical question. The question says that what is equilibrium constant, what is Kc for the following equilibrium when the equilibrium concentration, now that means that equilibrium concentration has been arrived and they will be having some values for each of the substance, and we are giving some values for SO2, O2 and SO3. Don't get confused by seeing this number and don't get fearful also, okay. Just remember the rule. Whenever such kind of number based questions are given, in the earlier part you were given the expression question. Now you have to write the numbers, you have to put the numbers. So in order to put the numbers, first convert everything into equilibrium constant. First convert everything in the form of expression. So let's convert everything into equation. First we have to take right hand side into consideration. We have to check our rule that whether it is a gas. Yes, it is a gas. So we will take this into consideration. If it would have been solid, we would have ignored it. So how we will write this 2SO3? We will write it simply as SO3, okay. And this is our capital C raised to the power small c, capital D raised to the power small d. It is not necessary that two expressions have to be there. One expression can be ignored also. It depends on the question. And SO3 raised to the power 2. Now we have to take left hand side, the reactant side. Product side we have taken. Reactant side is the left hand side, and we have to check whether everything is gas. Yes, everything is gas. We will take both these numbers into consideration. So we will write SO2 raised to the power 2 and O2 simply raised to the power nothing, or raised to the power 1 simply you can write down, or you can ignore also, okay. Now you have to just put the values which are given in the question. Is value of SO3 given? Yes, value of SO3 is given. So we will write down 1.90 raised to the power 2, okay. Is value of SO2 given? Yes, value of SO2 is also given. 0.60, okay, raised to the power 2 multiplied by, is value of O2 given? Yes, value of O2 is also given. 0.82, okay. This M indicates molarity or simply moles. Guys, Just remember one thing. Sorry for interrupting you in between. This equilibrium constant in chemistry, it is regarded as unitless quantity. Okay, it is regarded as unitless quantity because its units its units can vary. It is not constant. That is why it is regarded as unitless quantity, because its units can vary. They are not constant. Okay. Now you can pause the video and solve these numbers. Solving these numbers become bit difficult, become a little bit typical for the students. But if you are having maths, then you are very much comfortable in this. So after solving, it will give you 3.61 upon 0.295, which will come out to be 12.23 is the answer. So you have found out equilibrium constant by putting the values, and 12.23 is your answer. Okay. Now some other type of questions can also come, in which first of all the question will already give you equilibrium constant. Earlier what we were doing, we were making the equilibrium constant expression, but here equilibrium constant expression is given to you for a gas reaction. It is given for a gas reaction, and you have to write balanced chemical equation as per this expression. Okay. First of all, you have to make the expression of LHS with RHS, and then you have to check whether whether that equation that is derived according to your expression is balanced or not. Okay. And this is also very easy if you remember the rules, guys. We know that in the numerator part always consists of always consists of products. Okay, this is right hand side of the expression, and the denominator part is comprised of reactants, which is the left hand side. Okay, so simply how will you write this? NO4 H2O6. Simply write NO plus H2O, then write 6, and here it is given as 4. Then make an expression for this. Okay, this was the reactant part which comes in the left hand side, and the right hand side will come as. So how you will write this NH34? Simply write NH3, here you write 4, plus O2 raised to the power 5 was given, you can write 5 as this. Now guys, you have to check whether this equation is balanced or not. So how you can check this? First of all, if you will look at this, it has 4 nitrogen on the left hand side. Okay, 4 nitrogen are given on the right hand side also. Now there are 12 hydrogen, 6 into 2, 12. So there are 12 hydrogen on the left hand side. 4 into 3, 4 3s are 12. Again it is having 12 hydrogen. Now we have to look for the oxygen. 4 oxygen plus 6 oxygen, 10 oxygen are there. Here 5 into 2 is 10. Okay, then you can say 10 oxygen are there. So everything is balanced. So you can say that, you can conclude that this is a balanced equation. This is a balanced equation. Okay, this is, guys, you have to do such kind of questions. So thank you very much, guys. I hope you have understood everything.